Yeah, take your time. I mean, you can take 20 minutes, half an hour, pick a topic. If you need a textbook, we got one too. But I think it's pretty, kind of, and you write a lesson plan for one class, and then a demo is for 10 minutes.
How many students?
It's kind of like an imagining practice tool.
Yeah.
You just want to see the teaching style for one
Okay.
class. Okay?
Okay. I should start? Okay. Oh. Oh, okay. So, okay. Hello and good afternoon. My name is Jonas. Maybe some of you have seen me before. Today's lesson is about equivalent ratios and rates, and you will soon see what that is about. First of all, a ratio describes the relationship between two quantities. A rate is a ratio that expresses distance or speed versus time. For example, to walk 3 miles in 1 hour is to walk at the rate of 3 miles per hour. The fraction or ratio 3 divided by 1 expresses a rate that has units of distance in the numerator and units of time in the denominator. So you will get more you will get to know these expressions later on. So we just continue with examples further. So, equivalent ratios. When two ratios are equivalent, an equal proportion exists. When this is the case, the two cross products are equal. So now I will show you what the cross product is. So 3 divided by 4 is equal to 9 divided by 12. And you see here, if I cross this product and 3 times 12, and I take this cross up here, so 4 times 9, then this should be equal if it's in proportion. So 3 times 12 is 36 and 9.4 is also 36. That means this is a proportion. These two fractions has a proportion. So you will see more example of this later. So now we look at new examples of equivalent ratios. So the question here is, are the two ratios a proportion? Why or why not? So we look at the first one here. So 5 divided by 9 is equal to 2 divided by 3. Is this a proportion? And if it is, how can you know that? Well, let's look at the answer. No, this is not a proportion because the cross products are not equal. So you cross up here, the 3 up there and the 9 up there, that means that 5 times 3 is 15, and 9 times 2 is 18, and that is not equal. That is why this is not a proportion. So let's look at the next example. 16 divided by 48, is that equal to 80 divided by 240? I give you 10 seconds more to think about it. Maybe you can use a calculator. But it is the same technique used, and in this case, yes, this is a proportion. The cross products are equal, because if you take 16 times 240, that is 3840, and in the same way, if you take 48 times 80, that is also 3840. So this is a proportion. And the last example, it's exactly the same way. You take this times this, and that times that. And if you, of course, you have to use a calculator here. If you do that, this will show that yes, this is also a proportion. The cross products are equal. And in this case, the product is 2.925. But in both cases, the product is the same. So it's a proportion. So we go on. This technique now you can use in problem solving. But first we have to set up some equivalent ratios. This is an example here. A machine extrudes plastic pipe at a rate of 5 feet per second. How much pipe is extruded in 60 seconds or 1 minute? So first of all, you have to set up a ratio for each rate. So first of all, we know that 5 feet per second. Then you can make this as a fraction, 5 divided by 1. Because it was 5 feet per 1 second. And then the unknown feet per minute. And in this case we call it x, and we divide it by 60, which is 60 seconds in 1 minute, of course. Then you set up this equation. So the first ratio, 5 divided by 1, equal to the other ratio, x divided by 60. Then you have an equation with one variable, which you can calculate. And you can use, of course, normal. You can divide this, you can multiply with the denominator up here and here, and then you get times 60 here and times 60 here, and that means this will go away, so you only have x left, and here it's 5 times 60, which is 300. And that means that in this case the machine can make pipe at a rate of 300 feet per minute. But also we can use the cross product as before, and in this case it's exactly the same. So they have here solution 2, the cross multiply. You multiply with 60 there and with 1 there, and you get the same answer. 5 times 60 is 300. And for me, I prefer this solution, this way of solving it. And we will see more example of this. But the answer was 300 feet per minute. I don't see any questions, so I hope everything is okay. Okay, let's go on. Another problem. Helen is going on a trip and she would like to be able to tell her family when she will arrive. She knows she can drive 60 miles in 1 hour. Her family lives 300 miles away. How long will it take her to drive to her family's house? So, first of all, you have to set up the two ratios. So, the first ratio is 60 miles in 1 hour. That is what you know she can do. The second ratio is 300 miles, but you don't know how long it will take. Then you can put the variable n, in this case n hours, or you can put x, it doesn't matter. This is the variable that we want to calculate. So the two ratios, 60 miles per hour, this is the first ratio, and then you have 300 miles in n hours. This is the one we want to calculate. So, and we do the cross product again. You multiply up here 60 with n and 300 with 1. So then you got 60n equals 300. And then of course you divide with 60 to remove, to only have n left, and you have to do the same on the other side. So this means that n will be 5. That means it takes 5 hours to drive 300 miles if Helen drives 60 miles in 1 hour. And always you can check your answer by putting in your answer in this equation. So 60 times 5 should be the same as 300 times 1. And yes, it is. So, new example. Problem 3. Henry wants to buy some candy. He wants to make sure that he has enough money. He knows that one box of candy is $2. He would like to know how much money it would cost to buy 15 boxes of candy. So now, before I go on, I want you to think a little bit about this problem. Try to put up your own ratios before I show you the answer. So I will give you some minute to try and do this by yourself. What is that? Oh, yeah. Yeah, quick guy here. But we have to maybe give the others a little bit time to do them themselves. Yeah. So now I will show you, and of course in this case it's not very difficult. You put the first ratio, $2 divided for one box, and then you put your variable, n dollars, divided by 15 boxes. And then you got your equation, and you do the cross product again. So you take $2 times 15 boxes, and then you have 1 times n boxes. And you have $30. Now I have a question here, 10. I don't really understand. So the first ratio is $2 divided by one box, because that's what it costs. And then you have the variable n dollars divided by 15 boxes. Not super difficult, I think. We go on. Next problem. Chris has a race car that has been clocked at a top speed of 1.4 miles per second. He entered it in a race where his car took 19 seconds to complete the course. How many miles long was the race course? So, same thing here. You have to put up the two ratios and compare them to each other to make them equivalent. And then you get an equation, and then you can solve it by. Now students are fast here. I have the answer 26.6, and let's check if it's correct. Yes, we have the first ratio here 1.4 miles divided per 1 second, and that is equals to m mile per 19 seconds. And then you do the cross product again, 1.4 times 19, and then m times 1, and then you have 26.6. I have only 6 listeners and 2 are very fast, so I hope the other ones also get this. Okay, next one. Stephen figured out that he could read 20 pages of his favorite book in 1 hour. In 2.5 hours, how many pages could he read? Yep. It's not very complicated mathematics, but the key here is the technique, how to use this technique in when it gets to more difficult numbers. But of course you do exactly the same. You put up the two ratios like this. 20 pages it's wrong here. It's wrong in the text here. I didn't write this, but it should be 50. The first ratio is 20 pages for 1 hour. That is the first ratio, and then you have the x pages, the x amounts, divided by 2.5 hours, and then the cross product means, of course, 20 times 2.5, and that is not what it says here, 20. This is wrong. I don't know why they did wrong here. It should be 50. So this is wrong. It should be 50. Okay, I see some students here have 40. I hope you can see why it should be 50. Okay, let's go on. We don't have very much more. I want someone, if you think this is too fast, can you please write to me if it's too fast. I will take it more slowly and I will do it again if there is some problem, okay? I see some Thai text and I'm sorry, I cannot understand that. Okay, I will go on. Now you have three examples of practice here I want you to do. So I will just leave these problems up here, and I want you to try and finish them. And I will give you some minutes to do this, and of course I will show you the answer later. It's 109.5 million bytes you should use in the equation, and the answer will be a time, how many seconds. Yes, we have one correct answer here. I will soon show you, of course. I want everybody to have a chance to solve it. Don't want to do it too fast. Yes. Okay. Student number 10 is very correct. So, okay, I will show you the correct answers, and like I said before, the most important thing about this practice is to set up the ratios comparing to each other, because of course you can solve the problems in different ways, but in this practice it's all about to put up equal equivalent ratios. But as we see here, we had one fantastic student who was very fast, number 10.
Yes. Can you ask the student ID equality points?
Yeah.
What's
He,
the student ID?
what's your name, number 10? Now you have your chance to shine. Tell us your ID, number 10. Student ID for number 10. You can be proud. Don't be shy, okay? What is your student ID? Number 10.
I'll have to call him. I'll have one more TA.
He's writing something in Thai now, I don't know.
We're going to find you.